What's going on, guys? It's Mr. Clever, and today we are going to be looking at comparing and ordering rational numbers. So before we even do any of that, we first have to understand what a rational number is. So please get out your graphic organizer I gave you yesterday. It should say ordering rational numbers at the top. Right below that, there's a sentence with some blanks that we need to fill in. So what that is the definition for rational number. So anything I write in red is going in those blanks. So it says a rational number is any number that can be written as a fraction of an integer, remember those guys, over an integer. All right, so a rational number is any number that can be written as a fraction of an integer over an integer. So what does that even mean? Well, for example, I could say 1/2 is a rational number because 1/2 is a fraction that has an integer, right? 1 is an integer over another integer. Both 1 and 2 are integers. I could also have something like -3 over 4. -3/4 is a rational number. -3 is an integer and 4 is an integer. Okay, so to be a rational number, all you have to have is a fraction of an integer over an integer. So what about something like 3? Just the number 3. Now, it may be tempting to say, well, 3 isn't a rational number because 3 isn't a fraction. However, isn't it true that we can write 3 as itself divided by 1? Right? So anything divided by 1 just stays the same. If I have 3 things and I divide those 3 things into one group, that one group is going to have all 3 things. So 3 is an integer and 1 is an integer. So 3 is a rational number. Now what about something like 4.5? Well, if I write that as a fraction, that would be 4 and 1/2. 4 is a rational number because that's just 4 over 1. And 1/2 is a rational number because 1 and 2 are integers. So that is also, technically, both of those are actually rational numbers as well. So at this point, you might be thinking, well, what isn't a rational number? And we are going to talk about that here in a second. So below those blanks you filled in, you should see this bullseye looking thing where it has some blanks and it's shaded a little bit differently. So this is kind of, you will get used to this as you take some higher level math classes, used to seeing number sets organized as kind of this bullseye. So the outer ring of our bullseye, we are going to have the rational numbers. So the blank beside numbers, you're going to write rational numbers. And then inside of that circle, we have integers, right? We studied those at the very beginning of the year. And inside those integers, we have these guys, which we talked a little bit about during integers, but we have the whole numbers. Okay? So what this is showing is that every integer is also a whole number. Okay? The set of whole numbers, remember whole numbers, you can write these examples in the small circle here. Whole numbers, right? That's your 0, 1, 2, 3, 123, right? Whole numbers are whole numbers, but they're not negative, right? There's no such thing as a whole number that's negative. However, okay, we get to integers, we have things like 3, 5, -2, -1, -123, right? So isn't it true that the whole numbers, the set of whole numbers is included in the set of integers? Remember our definition for the set of integers. That's every whole number and its negative opposite. And going from that, we can say that integers is a subset, or it's included in the larger set of rational numbers, right? So -123, right, which I pulled from our integer circle. Well, that's just -123 over 1, right? So every integer is also part of the rational numbers. However, we also have our fractions, right, our decimals, maybe some negative mixed numbers we can throw in here. However, okay, so please, actually, at this point, I'll remind you, on your graphic organizer, you should be writing some of these examples as I am, kind of in your circles, in your bullseye. However, beside that diagram, there's a little box that says non-examples of rational numbers. So what that means is, essentially, what are some numbers that are not rational? Well, it's numbers that can't be written as a fraction of two integers. So you may be thinking, well, how do I even figure that out? Well, it's a little bit tricky. I'm not going to make you find any numbers that are not rational numbers on a test. I would not do that. However, there's a few things we need to talk about. If I have the decimal 0.3333 on forever, which, well, I'll get to that in a second. You may or may not know, whenever we have something called a repeating decimal, right? We talked about that yesterday. We can use the bar notation and do 0.3 with a bar over top to say it's repeating. So you may think, oh, okay, a number that repeats, it can't be rational. However, 0.3 repeating is really just the fraction 1/3. Where we can't have something that's, where we can't have a rational number is when we have an infinite decimal that doesn't repeat. It just goes on and on and on and on and on forever. There's no fraction we can create. So for example, the number pi, and there's another number called e. E is equal to, I think, 2 points. Oh, let me check this. I don't want to get it wrong. I believe it's 2.73. Hold on one second. Good old Google. Okay, so e, yeah, close. 2.7182, and it's on forever. Pi is 3.14159 on forever. There's no repeating pattern, and the decimal never ends. So the symbol pi and the symbol e, there's nothing special about those. It's just symbols we use to represent these numbers. And when you get the geometry especially, this guy pi here will play an important role. But neither e nor pi, okay, are rational. Also, the square root of 2 is not rational. Okay, so here's 3 nice examples that you can have in that box. So if you want, you can look up some other examples or think of some other examples that might fall in the non-example box, but this is good for now. All right, let's move on. So our essential question for today, how can we compare rational numbers? And today we're going to look at one method specifically, and then tomorrow I'll show you some other kind of logical thinking methods that we can try or that we can use to help us compare and order these numbers. So first, this isn't in your book. This is something I just put up here. I want us to compare 2/5 and 4/5. And by compare, I want to know which one of these guys is greater. Is 2/5 greater or is 4/5 greater? Okay, well, before we even have learned any of these math terms, okay, our instinct should tell us that 4/5 is greater than 2/5, Or in other words, 2/5 is less than 4/5. That's because 2 is less than 4. And that is absolutely true. If we have 2/5 of something, well, that's less than having 4/5 of the same something. Okay? But that's only really the case whenever we have things called common denominators. Okay? When I say common denominator, remember, the top of a fraction is called a numerator, and the bottom is called the denominator. So common denominators mean they're the same, right? The denominator in both fractions, the whole that we're looking at, is both made up of 5, okay? However, that's usually not always going to be the case. It's not always going to be nice where the fractions are split into the same amount of parts. So let's look at example 1. Turn to page 272, and let's look at example 1. So we have two numbers, -1, these are mixed numbers, -1 and 5/6, and -1 and 1/6. And you may notice in your book, they have a number line, which is absolutely what I would recommend for this problem, going from -1 to -2. So be careful when we're ordering some of these. They might throw some negatives in there because we've already learned negative numbers, right? We've already learned these integers. So where would -1 and 1/6 fall? Well, it would fall right here, and then -1 and 2/6, -1 and 3/6, which is -1.5, -1 and 4/6, and -1 and 5/6. And then add another 6 to that guy, and we just get -2, right? Because it would be -1 and 6/6, which is just another whole, so -2. So here is -1 and 1/6, and here is -1 and 5/6. And we won't always be able to look at and compare numbers on a number line, but whenever we can, or if you are able to, okay, I would encourage it, because I think it's a lot easier to see. And if we remember that the further we go left, that is, what's the word I'm looking for? That is smaller, right? It's getting smaller, and as we move to the right, it's getting larger. So because -1 and 1/6 is closer to 0, it's closer to the positive numbers, it's not as negative as -1 and 5/6. We would say that -1 and 5/6 is less than -1 and 1/6. I think we're pretty good with that based on what I saw on the test from integers. I think you guys are pretty good with ordering negative and positive numbers. Okay, however, now let's look at, actually, no, don't try letter A. I think you guys are good with that. Let's look at example 2. So example 2 tells us, same page, fill in the circle with greater than, less than, or equal to make 7/12, less than, greater than, or equal to true to 8/18. Okay, so, wow. Right off the bat, okay, we really can't tell which one is bigger just by our instincts, right? They don't have a common denominator, right? One's 7/12 and one is 8/18. I have no idea what those would look like on a number line. And really, what I have here in front of you that you see, these little diagrams, right? This right here would represent 7/12 parts, and this would represent 8/18 parts. And from this, we can actually obviously tell that 7/12 is larger, right? It takes up more space. However, when we get into some of these larger denominators, it's simply not realistic to be able to draw these holes here and split them up into parts. Like if I try to split this up into, 18 equal parts, you can already tell that my parts are not all the same size because that's just human error. So when it gets to be a certain point, a certain size of denominator, it's really difficult to try to draw them out. Which leads me to the least common denominator. So let's look at example 2. So we have 7 over 12, and we have 8 over 18. What we want to think about is how can we transform these fractions so they have a common denominator. Because if we can get them to a place where we have a common denominator, we can just compare the numerators to see which one's larger and which one is smaller. So how do we do that? Well, we look for something that you may or may not have heard of before called the least common denominator. In other words, we're looking for a multiple, a multiple of 12 and 18 that is the same, right? We're looking for a shared multiple between the 12 and the 18. So multiple, just a refresher, multiples of 12, that would be 12, 24, 36, 48, right? That's multiples of 12. Multiples of 18, actually, I'll go ahead and write these out. 12, 24, 48, whoops, I missed 36, 36, 48. Multiples of 18, that would be 18, 36, what would be next? 50, 50, 50, 54. Okay? And if you're wondering how I got that, I just multiply 12 by one more each time. So 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. Same thing with 18. 18 times 1 is 18. 18 times 2 is 36. 18 times 3 is 54. So these are multiples of our denominators. So what we're looking for, I just listed them out so it's easier to see. What we're looking for is the least common denominator. In other words, we're looking for the smallest shared denominator. So looking at this list and this list, I see that they both share the denominator of 36. Okay? So that's the only common denominator I have written down, so that's definitely going to be the least. All right. Make sure you have this written down in your book. I'm going to erase the screen. All right, so 7 over 12 and 8 over 18 is what we have. We want to transform these fractions, into other fractions that have a denominator of 36. Okay? And really, we're not changing the value of the fraction. We're just changing what it looks like. So, for example, if we have 2/4, okay? If you're like me, you look at that right away and you want to simplify it to just 1/2, right? 2/4 is the same as 1/2. What we're doing is essentially we're going backwards. We're saying we're taking 1/2 and we're de-simplifying it, I guess, if you will. So we're de-simplifying these two fractions to the point where they both have the same denominator. And if you remember, to get 36, that was 12 times 3. And to get 36 for 18, that would be 18 times 2. So what I did the denominator times 3 to get 36. So I have to do the same to the numerator to keep the value of the fraction the same. So 7 times 3 is 21. So 7 over 12 is equivalent to 21 over 36. And if you're not sure about that, type in your calculator 7 divided by 12 and then 21 divided by 36 and you should get the same value. Same thing over here with 8 and 18. I did 18 times 2 to get me 36. So 8 times 2 is 16. 16 36. And right here, I can just compare 21 and 16 because the denominator is the same. Okay, the parts are the same size. They're split into 36. So 21 36 is greater than 16 36. So I can say that 7 over 12 is greater than 8 over 18. Okay, I know that was a lot of information all at once, but we're finding a common multiple or a common denominator, okay? And then we're multiplying our fraction by the factor. and we're essentially de-simplifying it, okay? We will practice with this for the next 2 days, Thursday and Friday, okay? So don't get worried, don't get stressed. I know this is a little difficult, especially coming virtually. So right now, I want you guys to try letters. No, we're not going to do B. The got it problem B at the bottom of page 272. That's 5/6 and 7/9. Okay, so give that a shot and then come back. All right, so hopefully you've had a chance to try letter B at this point. So the first thing you always want to look at is to see if the two fractions already have the same denominator. And in this case, they don't, right? 5 is over 6, 7 is out of 9. That means we have 5 parts out of a whole that has 6 and 7 parts out of a whole that has 9. Okay, just looking at it, I can't tell, and I doubt you can, which one is bigger. So we have to find the least common denominator. So let's start listing multiples of 6. Well, we have 6, 12, 18, 24, and 30. I'll just stop there. And then for the 9, multiples of 9, we have 9, 18, 27, 36. And I'll stop there, and I can already see that they share a multiple of 18. 18 is 6 times 3, and 18 is 9 times 2. So 5 times 3 is 15. 6 times 3, that gives us 18. So 6/5 is equivalent to 15 over 18. Same thing with 7/9. 7 times 2, which we get from figuring out what the least common denominator is. 7 times 2 is 14. And, of course, 9 times 2 is 18. Whoops. Where'd we go? There we go. So we're comparing 15/18 and 14/18. Well, 15 parts of 18 is certainly greater than only 14 parts of the same 18. Okay? Hopefully this is starting to make sense in your minds. Now, let's take a look at example 3. This is on page 273. All right, this is where percents are coming into play. So if you read it, it's a word problem. It says Mr. Wang's class, 20%. In Mr. Wang's class, 20% of students own roller skates. So I'll write that down. That seems like important information. 20% of students, own roller skates. Okay, 20% of students own roller skates, or roller shoes, I guess it says. And that was Mr. Wang's class, so I'll put an H. Mrs. Trevino's class, 5 out of 9 students. 9 students own roller skates, or roller shoes, or whatever they're calling them. Okay, and that was Trevino's class. So in which class does a greater fraction of students own roller shoes? Well, here we have a percent compared to 5/9. So let's look at this. All right. So 20%, right? Think 20%, that's 20 hundredths. Okay, so 20 over 100, we can simplify that by dividing 10 out from the numerator and denominator, and we get 2/10. So now we're comparing 2/10 and 5/9. Same idea. They don't have a common denominator, so let's find it. So I can already tell you a bit of a shortcut method for finding a common denominator. Okay, so think a common denominator always has, how do I want to say this? The common denominator always has these two guys as its factors. So what we can do is just multiply the denominators together. So 10 times 9 equals 90. So I know it's probably not going to be the least common denominator, but here's another trick. You don't always need the least. In fact, you don't ever need the least common denominator. It's just easier to work with. However, any common denominator would work. 90 actually does happen to be the least common denominator, but it always won't be that case when we multiply the denominators together. So 10 times 9 is 90. So that means we multiplied 10 times 9, so we have to do the same thing to the 2. So 2 times 9 is 18. 9 times 10, we have to do the same thing to the 5. 5 times 10. And we have 18 90ths and 50 90ths. So, of course, 50 90ths is greater than 18 90ths. Okay? There is actually a very, very, very quick way to do this problem without even finding the common denominator. But you're going to have to wait till tomorrow to learn that because I want you to know how to do common denominator first. Okay? All right. I know this has been a lot. Try letter F. You're ordering a set. Okay? You're ordering multiple numbers. Okay? You are ordering 23%, 21 hundredths, 1/4, and 1/5. Okay, so put those in order, work on that, come back, and we'll go over it and finish up. All right, so hopefully you've had a chance to try letter F. And here's another kind of strategy that I'll give you a sneak peek for tomorrow. And that's the fact that it's not always easier to put everything into fraction form. So far what we've been doing, you would put 21 hundredths as a fraction and 23% as a fraction, and then find common denominators between the four numbers, but that seems super difficult to do. So actually, an easy way to order a set of numbers, change them all to decimal form. Okay? 23% is 0.23. 0.21 hundredths is already in decimal form. 1/4, 1 divided by 4, that's a quarter, or 0.25. 1/5 in decimal form, that's 1 divided by 5. That's 0.20, 0.2. And at this point, they're super easy to order, right? So least is 0.20, then 0.21, then 0.23, then 0.25, and that would be the greatest. Okay? So in the problems that it gives you to order a set of numbers that are all in different forms, I would just encourage you to put them all in decimal form. Okay? You may need a calculator for these fractions, but I would hope that you would know 1/4 is 25%, right? It's a quarter, like 25 cents. Or I'm sorry, 25 hundredths. And I would hope you know that 1/5 is 0.20, okay? These are kind of the fractions that we should becoming familiar with and kind of starting to just memorize naturally what they are as a decimal and percent. All right? So I know that was a lot, but try problems 1 through 7 on page 275 for homework, okay? Try them. We're not even going to go over them tomorrow because I know it's a lot, but we're going to try some different strategies tomorrow that I think will make our lives a little bit easier, okay? All right. So enjoy the rest of your Wednesday. Give these problems a shot, and I'll see you bright and early tomorrow.